Modern AI agents built on frameworks like LangChain and LangGraph operate through non-deterministic logic. Unlike traditional software that follows rigid, predictable rules, these agents evaluate their environment to execute dynamic, multi-step operations. This functionality creates a conflict. The utility of an agent comes from its ability to autonomously query internal data and reach out to external tools. But that same flexibility challenges the static rules defining traditional security perimeters. If compromised through prompt injection or hallucination, an agent with unchecked access turns a single point of failure into an expanding blast radius. In a flat network, this agent becomes an open door for attackers to move laterally and access any connected system. To address this, we must move beyond the perimeter and build a defense-in-depth architecture on AWS, following the security pillar of the well-architected framework. To secure AI without destroying its utility, we need a production-ready blueprint built on multi-tier network segmentation, ephemeral compute environments, and active threat detection. The absolute baseline rule for this architecture is that an AI agent should never be directly exposed to the public internet. We begin by constructing the edge layer. User requests route through Amazon CloudFront and an application load balancer in a public subnet. Here, AWS WAF inspects Layer 7 traffic to block application-level attacks, like prompt injections, before reaching the backend. The agent itself, running in a LangGraph or LangFlow container, is placed in the compute layer. It operates entirely within a private subnet, with zero inbound internet access. The agent still requires communication outward to reach specific third-party APIs. We enable this by restricting all outbound external internet routing strictly through NAT gateways. For connections to native AWS services, we implement VPC endpoints using AWS Private Link. This routes traffic directly to the service over the AWS backbone, bypassing the public internet entirely. This multi-tier VPC architecture ensures the agent's execution environment remains physically and topologically isolated. If an attacker breaches the edge, the compute layer remains separated. Network isolation must be paired with strict identity controls. AI agents must never hold long-term static credentials or broad administrative permissions. Instead, we use IAM roles for tasks. This provides a restricted identity feeding directly into the container. Through AWS STS, the role vends short-term credentials that are dynamically rotated, ensuring access only lasts for the duration of the task. We enforce least privilege by using IAM policies that restrict operations to exact resource boundaries. If the agent needs to write to an S3 bucket, the policy allows access only to that specific bucket and nothing else. Beyond the agent's identity, we have to consider its state. Frameworks like LangGraph frequently checkpoint conversational memory to storage, which creates a target for sensitive data exfiltration. To secure this state data at rest, we use AWS Key Management Service for envelope encryption. The agent's memory is encrypted with a unique data key, which is itself encrypted by a master key, making the contents unreadable before it is written to storage. Combining temporary STS credentials with envelope encryption ensures that even if a container is hijacked or its storage is breached, an attacker only gains access to expired tokens and encrypted data. To prevent an agent from executing a tool escape attack and reaching a shared host, the underlying compute environment must be ephemeral and isolated. We achieve this by provisioning the agent on AWS Fargate. Fargate runs every task in a separate virtual machine, providing a higher degree of isolation than tasks sharing the same host. We integrate Amazon Inspector into the CI/CD pipeline and runtime environment to verify the integrity of the container images. It continuously scans the container layers for known software vulnerabilities and unintended network exposure, providing automated discovery in near real time. We further harden the environment by disabling SSH and RDP entirely, eliminating inbound administrative ports. When interactive debugging is necessary, operators use AWS Systems Manager Session Manager. This establishes an encrypted tunnel from the inside out, leveraging IAM for secure and audited administrative access. Utilizing immutable compute alongside portless administration systematically removes the host-level attack vectors that are typically exploited by hackers for lateral movement. Frameworks like LangChain require third-party API keys to access language models. These must be managed securely without hard-coding them in the application environment. We use AWS Secrets Manager for this. The agent retrieves the necessary API keys programmatically at runtime, ensuring that sensitive credentials never reside in the application's persistent storage. To defend the architecture in real time, we enable Amazon Guard Duty for machine learning-driven threat detection. It continuously monitors VPC flow logs, DNS logs, and CloudTrail data events to identify malicious activity. It analyzes these streams to detect anomalies, such as an agent communicating with a known command and control server or attempting to exfiltrate credentials. For a rapid response, we route these Guard Duty findings through Amazon Event Bridge. It triggers an automated remediation pipeline, instantly updating a WAF rule to block a malicious IP or automatically revoking the agent's IAM role. Secrets Manager removes valuable keys from the local environment, while the integration of Guard Duty and Event Bridge enables the environment to detect and remediate threats without waiting for manual intervention. This architecture replaces the vulnerabilities of a flat network model with a defense-in-depth design. We now have traffic filtering at the edge, Secrets Manager handling credentials, Fargate isolating compute, and Guard Duty monitoring the account. Strict network isolation and least privilege IAM identity successfully constrain the unpredictable, non-deterministic nature of the agent. Immutable compute and automated threat detection work together to minimize the blast radius of any potential exploit. Deploying enterprise AI requires a shift in perspective. Because the agent initiates actions across services, it must be treated as an active machine identity, governed by the same strict primitives as any other user. Secure AI deployment is not about achieving perfectly predictable logic, but about building an infrastructure that assumes compromise and systematically limits the consequence.